Right now, you are probably sitting within arm's reach of a glass bottle. Maybe it's a soda bottle on your desk, a sauce bottle in your kitchen, or a glass jar in your fridge. You've touched thousands of them in your lifetime. You've opened them, poured from them, recycled them, maybe even broken one on accident. But here's the thing. Have you ever stopped and thought about what it actually takes to make that glass bottle? Because what happens inside those factories is absolutely mind-blowing. We're talking about temperatures hotter than lava. We're talking about machines that move faster than your eyes can follow. We're talking about a process so perfectly engineered that a single factory can produce over 1 million glass bottles every single day. And most of them come out flawless. So today we are going to pull back the curtain and take you inside the world of glass bottle manufacturing. And trust me, by the end of this video, you will never look at a simple glass bottle the same way again. Let's go. Before we even get into how bottles are made, we need to answer one basic question that most people get completely wrong. What actually is glass? Most people think glass is a solid, and technically it kind of is, but it's not like metal or wood. Glass is what scientists call an amorphous solid, which means it doesn't have a neat, organized crystal structure like most solids do. Instead, it's more like a liquid that has been frozen in place so quickly that the molecules never had time to arrange themselves into a pattern. Some people even say glass is a super-cooled liquid. Now here's something wild. The main ingredient in glass is sand. Plain, ordinary sand. The same stuff you walk on at the beach. Sand is mostly made of silicon dioxide, and when you heat it to an extreme temperature, it melts into a liquid. When that liquid cools, you get glass. But here's the catch. Sand alone melts at around 3,100 degrees Fahrenheit. That's insanely hot and incredibly expensive to achieve in a factory. So manufacturers figured out a smarter way to do it. They add 2 additional ingredients, soda ash and limestone. These 2 materials act as what chemists call fluxes. They lower the melting point of the sand down to around 2,600 to 2,800 degrees Fahrenheit. It's still brutally hot, but much more manageable for industrial production. There's also a 4th secret ingredient that almost nobody talks about, crushed recycled glass, which manufacturers call cullet. Adding cullet to the mix lowers the melting temperature even further, reduces energy costs, and also makes the whole process much more environmentally friendly. In fact, most modern glass bottle factories use anywhere from 25% to 70% recycled glass in every single batch they produce. So that old bottle you tossed in the recycling bin? There's a real chance it came back to life as a brand new bottle on a store shelf near you. Every glass bottle starts its journey in what the industry calls the batch house. This is essentially a giant mixing and storage facility where all the raw ingredients are measured, blended, and prepared before they enter the furnace. Workers and automated systems carefully calculate the exact recipe for the type of glass being produced. Different bottles need slightly different compositions. A wine bottle needs specific optical clarity. A beer bottle needs extra UV protection so the light doesn't ruin the beer inside. A medicine bottle might need a very precise chemical resistance. Once the recipe is calculated, the ingredients, silica sand, soda ash, limestone, various minerals, and cullet, are mixed together in huge proportions. A large glass factory might mix hundreds of tons of raw materials every single day. After blending, the batch is transported via conveyor belts into a massive industrial furnace. And this is where things get truly incredible. The furnace is, without question, the most impressive part of any glass bottle factory. These are not your average ovens. The furnaces used in glass production are called continuous tank furnaces, and the name says it all. They run continuously, 24 hours a day, 7 days a week, 365 days a year. Once a glass furnace is lit, it doesn't stop. These furnaces can run for 10 to 15 years straight before they need to be shut down for maintenance. Turning off a furnace and cooling it too quickly can actually crack the entire structure. Inside the furnace, temperatures reach between 2,600 and 2,800 degrees Fahrenheit. To give you some perspective, the surface of lava from a volcano typically ranges from about 1,300 to 2,200 degrees Fahrenheit. So yes, the glass inside these furnaces is literally hotter than volcanic lava. The raw batch materials are fed into one end of the furnace continuously. As they travel through the furnace over a period of 20 to 30 hours, the materials gradually melt together and undergo a series of complex chemical reactions. Gases escape, impurities burn off, By the time the molten material reaches the other end of the furnace, it is transformed into a smooth, clear, glowing liquid, molten glass. Here's something most people don't realize. The color of glass isn't added later. It's determined right here in the furnace. Clear glass gets a very precise batch with no added colorants. Green glass gets iron and chromium. Amber glass gets iron and sulfur. The color is baked right into the glass at the molecular level, which is why you can't scratch it off or paint over it with anything that lasts. Now we reach the part of the process that is arguably the most fascinating and the most technically impressive. The molten glass, glowing at around 2,100 degrees Fahrenheit, flows into the forehearth. At the end of the forehearth, a mechanism called a gob feeder cuts the flow of molten glass into precise individual drops called gobs. Each gob is a perfectly measured portion of glass, the exact amount needed to make one bottle. The gobs are cut at a rate that can exceed 200 per minute, and they fall into the forming machines below. The machines that shape glass bottles are called IS machines. A modern IS machine might have 10, 12, or even 16 sections all running at once. The first method is called the blow and blow process. The molten gob drops into a mold called a blank mold. A puff of compressed air blows into the top, forming what's called a parison, a rough preliminary shape. The parison is then transferred to a final mold, flipped upside down, and another powerful puff of compressed air is blown into it from below. This air pressure inflates the glass outward until it fills every contour of the mold perfectly. The second method is called the press and blow process. In this approach, a solid metal plunger is pressed into the glass to create the initial hollow shape. This method is generally used for wide-mouth bottles and jars. The entire forming process, from the moment the gob falls into the blank mold to the moment a finished bottle comes out, takes just a few seconds. A single machine can produce hundreds of bottles per minute. Here's something that most people completely overlook. A newly formed glass bottle, fresh out of the mold, is actually dangerously fragile. That might sound strange given how tough glass bottles feel. The reason is thermal stress. When the bottle comes out, the outside surface cools faster than the inside. This creates tension within the glass. If you try to use it, it might shatter from the slightest impact. To fix this, every bottle goes through a carefully controlled cooling process called annealing. The bottles travel on a conveyor belt through a long tunnel-shaped oven called a layer. The temperature is gradually reduced over a period of about an hour. The glass is slowly and evenly cooled from around 1,000 degrees Fahrenheit all the way down to room temperature. This allows the molecules to settle into a uniform, stress-free arrangement. After annealing, every single bottle passes through one of the most impressive quality control systems in all of manufacturing. This is the inspection stage, and the level of precision here is almost unbelievable. Modern glass bottle factories use high-speed automated inspection machines packed with cameras, sensors, and lasers. These machines scan the bottle from multiple angles, dozens of times per second. The inspection system checks for an astonishing number of potential defects. It checks dimensions, wall thickness, and the finish at the top where the cap goes. It looks for cracks, stones, bubbles, or thin spots. If any bottle fails even one of these checks, it is automatically diverted and sent to be crushed and recycled as cullet. The industry standard for defect rates is incredibly tight. Many operate at less than 1%. There's also a human element. Trained technicians regularly pull sample bottles for manual checks, including pressure tests, impact tests, and thermal shock tests to ensure the line is performing correctly. Once the bottles pass inspection, they often receive 1 or 2 protective coatings before leaving the factory. The first coating, applied hot, is called a hot end coating. This is typically a thin layer of tin oxide that bonds to the glass surface, improving structural integrity and adhesion. After annealing, a second cold end coating is applied. This is usually a polyethylene wax that makes the bottle surface slightly slippery, allowing them to slide smoothly without scratching. Even microscopic scratches can significantly weaken glass. After coating, the bottles are packed into pallets, ready to be shipped to beverage companies, food manufacturers, cosmetics brands, and many other industries. Let's take a moment to appreciate the scale of what we just walked through. The numbers are truly mind-blowing. A large glass bottle manufacturing facility can produce over 1 million bottles per day. That's approximately 700 bottles per minute coming off the production lines. A glass bottle is 100% recyclable and can be recycled endlessly without any loss in quality. The United States alone produces approximately 25 billion glass containers per year. In a world increasingly dominated by plastic and aluminum, you might wonder, why does anyone still bother making glass bottles? The answer is simple. Glass has properties that no other material can replicate. Glass is chemically inert, meaning it doesn't react with its contents. It doesn't leach chemicals or absorb odors. When you want the contents to taste exactly as intended, glass is the only option. Glass is also the most sustainable packaging material at scale. It's made from abundant, naturally occurring raw materials. A recycled glass bottle can be back on a store shelf within 30 days of being recycled. The next time you crack open a cold glass bottle, you'll know that what you're holding started as a pile of sand, was melted hotter than lava, shaped by a puff of air, and traveled a long road just to end up in your hand. And here's a question I want you to answer in the comments right now. And I'm genuinely curious about this. Do you think glass packaging is better than plastic? Or does plastic win for convenience? Drop it in the comments below. Also, here's a fun challenge. Go look at the bottom of a glass bottle near you right now. You will see a small number molded into the glass, usually between 1 and 80. If you find one, drop the number in the comments. I'm going to check and respond to as many as I can. If you learned something new today, hit that thumbs up button. And if you want to keep learning cool stuff about how everyday things are made, hit subscribe and turn on notifications so you never miss a video. Thanks for watching all the way to the end. I'll see you in the next one.